the other day. My fault. I bumped a bottle of rubbing alcohol down onto top of a computer and kind of fried everything. So we'll be starting in a second, just starting the countdown on the YouTube and Facebook and everything else. Thank you for being here early. And hopefully I'll just end up with an Instagram stream key so I can just go. I mean, come on, just stop making it hard on everybody. You know that all the spammers are using their computers to do it, so why make it hard on everybody else? Same with TikTok. Oh, and yeah, let me take this thing out of my mouth so I can actually talk. Sorry. There we go. That feels natural. All right, here we go. Welcome to Evidence-Based Audio, number 223. And this one's going to be Mike Magic and FRFR. All right. Now, first of all, I guess I had to say something. I know that I'm doing more and more live sound now, so of course, I don't know if you haven't heard about this. Maybe you have, maybe you haven't. There was this Blue Ridge Rock Festival. So, and I know this is a horrible source, Loudwire. They get a lot of stuff wrong all the time, but let me just read some of what they had to say. In the weeks after the abrupt end of this year's Blue Ridge Rock Festival, which was canceled partway through its 4-day weekend on September 9th, more information continues to come to light. Earlier this week, Alton, Virginia's WSLS spoke with two stagehands about the conditions and the hot mess of a situation the overall had become. Attendees and various festival personnel had previously documented what they saw and experienced on site. Let me see if I can swing, because there were some videos with some hilarious, well, I don't know how funny it would have been at the time to be in there, but showing the conditions of what was going on there. And I mean, this is like one step above the Fire Festival as far as I know. And we just had a disaster right here in Hawaii where we had this greedy promoter that wasn't letting people bring water into an outdoor concert where, you guys may know, I'm really an Arizonan, and the Warp Tour, I think it was Warp Tour. It was a pretty big tour. Actually, pulled that same shenanigans over there, not allowing people to bring water in so they could sell it to you. Over there, that's deadly. And in Hawaii, it can be deadly as well. I mean, it doesn't, I know you don't think so, but it really can. So let's see some of these pictures here. View this post on Instagram. So I'm not really seeing anything. Bunch of garbage. People can't get anywhere. Very little garbage pickup. Employees were being told to take showers at a town nearby at like a 24-hour fitness or something. With just garbage everywhere. People waiting like 12 hours to get their campers in or whatever. I mean, it was just absolutely nuts. So I saw this from Tank the Tech. Well, yeah. One of the promotion companies, I saw this. They did a strike. Strike, no showers, no stagehands. So they just left, right? That's look, hey, I know I always say it, the show must go on, but you know what? If somebody's that abusive, just say no. Just leave. Fine. That's not on you. So yes, this picture here, strike, no showers, no stagehands. I read another thing about another company that went on strike. They're claiming it was because of the weather, but I'm sure it's not. So let me read more. Ranging from overflowing garbage, filth-covered bathroom and shower facilities, hours-long waits for shuttle buses, inadequate space to shelter during a storm evacuation, weather-ravaged campsites, insufficient water facilities, parking issues, worker strikes, and more. One of the things they said was snakes. And I'm like, you know what? I'm okay with that. I'm a herpetologist, man. I want to see the snakes. Now I saw this because of Tank the Tech. If you follow any PA type of things, you know, two of the ones to really watch are Tank the Tech and Dave Rat. Let's see. Stagehand Devin Taylor provided the local news outlet with footage of living conditions. Immediately, I was just greeted with the smell of mold. I don't care. It was dilapidated and run down. Don't care about mold. Showers were often inoperable. I saw the thing like they didn't have enough flatbeds to move the gear around. They dropped a video wall on somebody. I mean, this is bad. Prior to the cancellation, the stagehand struggled to properly get things set up on festival grounds. So it's Tank the Tech. He called the event unsafe and argued people need to be held accountable in this business. I'm so tired of things happening where nobody has any accountability. The fans were treated horribly. The crews were treated horribly. The staff, the bands, nobody should have to experience this ever. And, you know, Tank mentions this. I talk about this all the time. It's scary for people in the industry to speak out about anything because they may be blacklisted. They may be, you know, there's a lot of cancel culture nowadays, but, you know, in the entertainment business, there was always cancel culture. So you don't really want to rock the boat, but, you know, if it's this bad, I don't care. You tell your friends and they don't go. You know, there's no reason to hurt people. Now, Tank the Tech did a video about it. I know he's a beardo, but, you know, he's okay. If you take a look, it's called A Tour Manager's Experience at A Tour Manager's Experience at Blue Ridge Rock Fest. And I'd go watch it. He brings up a lot of points. Like, some of the stuff is absolutely terrifying, man. Like, so anyway, I'm gonna go on. There's a long thread about over at Safe Space. They're talking about microphones. Now, this one's called low budget microphone that can compare to a U87. And I know we talk about mic magic and magical pixie dust and magical beans and crap all the time on here, but, you know, microphones do different things. But they're not made out of magic. It's not anything that we don't understand. If you want a mic to sound a certain way, we know how to make that. There's no secrets. There's no black magic. There's no, I mean, it might take you a couple tries in engineering to get there, but we know how these things work. But people, it's religious nuts, man. They believe that mics were made at a certain time. They can never be made again, whatever. But microphones are no different than any other audio device. You know, you put something in one end and something comes out the other end. And in this case, you know, what do you care about? The frequency response, like anything else, the noise, the distortion, the bandwidth. And with microphones, there's a lot of things that happen, like on-axis, off-axis response. And those things do make a difference, but you can generally make them sound pretty much the same. I mean, I know nobody wants to hear that, but, like, you know, Slate's doing pretty good with their modeling microphones. If you have two capsules, you can really do a lot with this stuff. You can really, really, really change how all of these parameters act. And but there was a video that came up. We're going to watch a little bit of this, and this is Neumann U87 AI versus Audio Technica 4050. Okay.
Hello. Now I am going to sing you a song I have written.
Okay, here we go.
Χαμόγελο και δάκρυ μου, τα πάντα θα σου δώσω.
So it's switching back and forth between the Audio Technica 4050 and a Neumann U87 AI. You may or may not hear a difference there. I don't think that anybody who's not an absolute zealot believes that the end user, the audience, the person listening to the song, hears a difference or or would care either way which one of those two was, but maybe you care. But I said when I talked about this thing, what did I write? I wrote some snarky thing, but it's true. Let's see, where is my... Okay, so I responded to that. So I said, I hear the difference of a free EQ, like the one that comes with your DAW. And what I'm saying is, the difference between those two mics, in the context of a mix, with all the other instruments and junk going on, even if not, honestly, you could take an EQ and make one sound so much like the other that I don't think that in a random, proper ABX test, even the zealots would be able to tell the difference. So one of the zealots who's normally on Safe Space says, oh, so you think an EQ will turn a 4050 into an 87? That's a straw man, but, you know, I kind of let it go, but I said, I said, no, I know that an EQ will change the recording in the first clip into something you can't ABX greater than chance from the second clip. And what I'm saying is, an EQ would take that original track and get it so close to the other one that I don't think you'd be able to tell me which one is which. You might still hear a difference, but I don't think you could tell me which is which. So he says, lol, if you say so, a nice swerve on actually answering, but I did answer. I said I answered even though it was your straw man, and I posted the receipts. So anyway, I'm sure I said something snarky. Oh, he says, I choose not to post tests or whatever, as neither you want to see the other points of the particular puzzle. Making a claim about what I hear in my head. I don't want to get into YouTube drama or whatever. But so let's look at something from, who is this from? Fowley. So this is a thread called A Deep Look into Mic Modeling and Cheap DIY versus Commercial Solutions. Okay. So a commercial solution of mic modeling might be something like the Slate VSX system, right? Is that what it's called? Slate VSX? Slate VSX, or is that the headphones? That's the headphone one. Slate modeling mic. Let's see what that is. Because there's two of them. They got a condenser one and another one. So let's see. That is the, if it's going to load. Virtual mic, VMS, yeah, virtual microphone system. So supposedly you take this dual capsule mic and then you put this plug in on it, and it makes it sound like all these other mics. And with the dual capsule one, I could see it doing it, honestly. Maybe not so much with the single capsule version, the ML2 or whatever, but anyways. So let me read this to you. So Fowley's saying, as some people requested it, I'll show you how it's possible to transform one mic sound to another, and I'll try to explain the limits of this technique. I'll provide recordings to listen to where modeling works and where it doesn't. For those who don't care about mic modeling, I think you'll still stumble upon some interesting things here. I will only cover cardioid pattern here because it's the most common and most multi-pattern mics are tuned to it. Again, yes, it's cardioid, but I know people can fight about wide cardioid, narrow cardioid, hypercardioid, supercardioid. I think we're talking about your basic cardioid with the lobe in the back. Let's look at some pictures. Let's see. Cardioid mic pattern. Just so you know what we're talking about here, in case you don't. Here we go. So here's the thing of microphone polar patterns. So cardioid, turn that upside down. Looks like a heart, right? That's how you remember this cardio heart. That's your cardioid pattern. Here's supercardioid. See that lobe in the back? Hypercardioid with a bigger lobe in the back. Omnidirectional, where it picks up around everywhere. Figure 8, shotguns. So here's what we're talking about, cardioid, okay? So about the measurements, you'll see. There's no way I'm paying €300 minimum to consult the IEC standard 602 68-4, I'll do measurements my own way so they can't be compared to what manufacturers deliver. And there are, I know it sounds like it's so easy to test things. It's really not. So there's a lot of different test standards and conditions, and there are some pretty strict ones, which are great because then you're comparing apples to apples. But as long as you really change only one variable at a time, a lot of different tests will work. And so he's saying measurements have been done in an anechoic room using a custom coaxial speaker with finite impulse response correction. This particular setup is normally used for HRTF and 3D audio research. So if you guys have ever seen like Jecklin discs or dummy heads or any of that kind of thing. So low frequency accuracy is absolutely not the focus. With that in mind, I did both near field and far field measurements and combined them to get the best signal to noise ratio, the least amount of distortion, and no proximity effect. I don't know. You guys let me know if any of these terms you want to hear more about them, like proximity effect or whatever. I'll talk about it, but it's going to go on assuming you either know this stuff or don't care about the nitty gritty, because it's not all that important as long as you understand the basic concepts. The measurements have been acquired using a high quality discrete preamp and analog to digital converter that are completely transparent. I know people are going to take issue with that statement right there big time, but I don't care. As the speaker has an F3 of roughly 40 hertz, I've gated the measurements starting at 50 hertz, and they have been ERB smooth for the most intuitive reading and best accuracy for modeling purposes. And this is a lot of jargon and stuff, but basically he's saying he's setting test conditions so that we can actually test apples to apples, okay? For those who want to download all the example recordings in one go, here you go. I'm going to grab these right now. Holy crap, download all, okay. Okay, we'll deal with that in a second. So what is mic modeling? So he says, let's briefly talk about the more known types of modeling here, analog circuit emulation. In DSP, we can differentiate between two approaches. And so this is really how you're talking about different types of mic modeling. One is physical modeling. If we think about a piece of analog gear as a box with an input and an output, and we try to recreate what's happening in between, we can look inside and try and recreate the behavior of the electronic components. So physical modeling, think about SPICE, like circuit simulation. You would, let's say, try and come up with an equation that tells what a resistor does in a circuit, what a capacitor does, what a transistor, what a tube, what all these different electronic components, and then you physically, or you make a mathematical algorithm that simulates the effect that's happening because of those physical components. I mean, look at what it's done to amplifier guitar amp circuits. It's unreal, man. There's other ways. 1 second here.
Who is it?
So physical modeling is one way to go about it. I think that's the way the Helix does. That's the way Fractal does. For the most part, I'm sure it's a mix of there's some hybrid techniques and stuff, and not just modeling. Sometimes you're not modeling at all. Sometimes you are just adding DSP. Okay, so the other one is signal modeling. We can measure the way the box changes the signal and try to recreate its behavior with a set of equations that could process the signal in a similar way without even looking at the components inside. This is fine for emulating systems that don't have hidden internal states with a behavior that can be characterized with a limited set of measurements. Most guitar amp profilers use this technique. So think about your Kemper, think about your Quad Cortex's amp capture, ToneX right now, that's the big one from IK Multimedia. And of course, NAM, the neural amp modeling, that open source one from Stephen Atkinson that everybody's talking about right now. It can also be used alongside physical modeling in what we call hybrid modeling. And so you might capture, like with the Kemper or whatever, you capture a certain thing at a certain state, but you're still going to model what the knobs are going to do in order to maybe have more range of control than you would with the actual real device. So he says mic modeling is all about signal modeling. However, that's not strictly true, but let's go with what he's saying. However, the signal arriving at the capsule is a bit more complicated than an electrical signal transversing a copper wire. It can receive sounds from one direction or several. It sometimes doesn't even have a preferred direction. We'll see later in more detail how it poses a problem. So we're talking about now that sound is coming from everywhere. And so it's not the same thing as when you put a signal into the input of a device, like through a 1/4 inch or XLR cable or whatever. This is actually a membrane, the speaker. Basically, a microphone is a speaker in reverse, right? So you have this big membrane flapping back and forth, and sounds can enter that thing from all over the place. And depending on what direction they enter from, they'll change the sound that comes out. So that's tricky. All right. So he says, number 2, how is it possible? The thing that makes mic modeling possible is the fact that microphones are minimum phase devices. It means that every frequency has the least amount of delay mathematically possible, according to the magnitude response of the system. Also, those systems can be inverted, as explained in Rumi Q Wizard's website. So here's a quote from there. Minimum phase systems can be inverted, which means that a filter can be designed that, if applied to the system, would produce a flat response and the correct phase response at the same time. That is clearly a nice property to find if we want to apply the EQ. So this is a hard concept to grasp. Basically, it's saying, now Ethan Weiner has done a lot more about this, but there are a lot of, like, you know, when they talk about time, you crack an egg. You can't reverse that flow of time and put the egg back together. I mean, you really could if you could actually reverse time. But once you've done it, you've fundamentally changed. Like, you cracked the shell and everything. Like things have happened that just can't be undone in any sensible way. But in the case of many EQs, you can actually reverse the EQ and come out with a nulled signal just by doing exactly the opposite. And we actually test that all the time with nulls, right? So he says, so we can apply this principle to transform both the magnitude response and the phase response of one mic to another. So again, because signals can hit a microphone's membrane at different times in different places, this off-axis response, the phase response and stuff, becomes pretty important. So number 3 says, but frequency response isn't everything, right? So A, transient response. It's easy to think that frequency response can't properly describe the transient response of a system. It's true, but not for minimum phase devices, because every frequency has only one value of delay possible that is calculated from the magnitude response. A common misconception is using impulse responses to describe the transient response of a minimum phase system, such as a microphone. Actually, a common misconception is using impulse to describe the transient response of anything. It happens way too much. Maybe we don't need to go into that right now, but it's an annoying pain what people put on forums from time to time. Here I measured the impulse response of a condenser versus the dynamic mic, and so it shows a 414, which is a condenser, versus a Blue Encore 100i, which is a dynamic mic, and you can see one thing's in orange, one thing's in blue. And you can see the differences in the waveform, though the initial spike sure looks about the same. So he says, it's easy to look at this graph and think the big dip from the dynamic mic comes later than the condenser mic, so its capsule is slower. It's also more pronounced, so it means the capsule vibrates more after the impulse. It's true, but the fact that the capsule of the dynamic mic can't vibrate as fast as the one from a condenser mic just means one thing. It will capture less high frequencies. Here, after measuring the two mics' magnitude responses, I've applied a minimum phase EQ so that the AKG 414 has the same frequency response as the blue mic. And once I do that, the overlap on those two signals is incredibly similar. So it says, so it's not exactly the same, probably because there's a margin of error with my measurement setup, but you get the idea. The fact that the 414 is able to match so closely the vibrations after the impulse is explained with the Gibbs effect. And let me just get a quick one of the Gibbs effect. In mathematics, the Gibbs phenomenon is the oscillatory behavior of the Fourier series of a piecewise continuously differential periodic function around a jump discontinuity. Let's see if somebody puts that in a similar thing. As more Fourier series constituents or components are taken, the Fourier series shows the first overshoot in the oscillatory behavior around the jump point, approaching 9% of the full jump, and this oscillation does not disappear but gets closer to the point so that the integral of the oscillation approaches to zero, i.e. zero energy in the oscillation. And one of the ways that you can describe this is by showing square waves. It's getting super crazy complicated. I don't mean to go too crazy, but if you want to go look up the Gibbs effect, probably better to watch a video on it. I think it's probably better to watch a video on everything nowadays. All right, so we go to B, nonlinearities. And I got a big problem with this one in the first place. We're not going to, in fact, that thread we were talking about, I actually answered a big thing about the nonlinear. And when people talk about character of mic preamps and stuff, they're talking about nonlinearities. They're mostly full of crap. You're not using your mic preamps in that kind of situation. You're keeping them in the linear range for the most part, especially microphones. Okay, so but he's going to say it anyway. So nonlinearities such as compression and harmonic distortion play an important role in microphones, but one has to understand the audibility of such effects. So when does this kind of stuff reach the threshold of perceptibility, especially in a mix, But more than that, are you operating your mic in a nonlinear fashion? I do not know of any mic that has a compression circuit built inside, so we'll consider that any compression happening is because the capsule and the electrical components are distorting when approaching the limit of their headroom. The human audibility of harmonic distortion has been thoroughly researched, and the thresholds from these studies is around 1%. When we consider the fact that harmonics can add up, all right, I'm not going to touch that for now. Okay, we're going to leave that we're going to leave that statement be, but there's a lot to that. I can't just necessarily let that slide, but that's not going to hurt what he's saying here. And EQ can affect the audibility of such distortion. The most common total harmonic distortion audibility threshold used by the microphone industry is 0.5%, so that if the THD is below that, it's unlikely to be heard in most situations. This threshold is also called max SPL. Now, there are scumbags out there that'll give you the max SPL as actually the maximum amount of pressure where the microphone still puts out anything. We like to say max SPL is where 1% distortion happens, or a certain amount of distortion happens. It's still working, but man, you are running out of headroom completely. So it says the max SPL for most tube microphones is about 110 to 120 decibel sound pressure level. For transformerless condenser mics, it's around 140 sound pressure level. For dynamic mics, it's usually between 140 and 160 dB SPL. To know what this translates when recording, here's an SPL chart that compares different sources' mic distances. And, you're comparing, like, how far away are you putting a microphone and what kind of SPL is actually hitting the microphone there. And in general, unless you're talking about something ridiculously loud, pretty much any modern mic can handle the volume that you're going to be recording. Snare drum, it's going crazy. So at 30 centimeters, 128 decibels, it's loud as hell. At 3 centimeters, which is about where a lot of people put their 57s, it's 148 decibels. So now you're at the upper limit of what a microphone can do. Kick drum, trumpet, they're pretty high up there. Saying 140 for grand piano. I hope not, but I don't know that you'd mic a grand piano that close. But kick drum, you might. Kick drum maybe 7.5 centimeters to saying 133 decibels SPL. It's a lot. But again, even a modern condenser mic will probably handle that okay. Okay, so it goes further. So above the max SPL of the mic, the distortion will start to become audible. So let me say this again. And he bolded start. So I'm going to say it with the bold. So above the max SPL of the mic, the distortion will start to become audible. The distortion is not audible before the max SPL. In this case, a minimum phase filter will not be enough, and we'll need to model the distortion too if we want the model to be 100% accurate. Given how high the max SPL is for most mics, I won't even bother. The sound of a tube has more to do with frequency response. All right, now that's a whole nother one. So that's, what do you call it, Mix Bus TV? He says this, and I love it, because most people in his position talk about tubes being warm. He says tubes are treble boosters, and he's right for the most part. In this case, they're doing tubes where they wipes the top out, but again, we're not operating mics in the nonlinear level. We are in the linear range, so we're not adding compression or distortion or whatever, or we're not trying to. So number 4. Now this is where people are going to argue, like, you know, you're never going to even come close, but it doesn't matter. Off-axis response. It's cool to model the behavior of a microphone with a source that is dead on axis in a room without any reflection, but that doesn't happen in the real world. So is mic modeling useless because the off-axis response can't be modeled? Well, we have to consider the volume of the off-axis sound and the way the microphone's frequency response changes with that angle. And again, if the difference between the two is below the guitar level in your mix, you're not going to hear it anyway. So he says, I've measured 3 famous large diaphragm condensers I had at my disposal with multiple angles, as well as the Townsend Sphere L22 modeling microphone. Here are some graphs of the frequency response from off-axis angles, weighted with the on-axis response, so we can compare how the response changes. It will tell us how far off our mic modeling will be. And for the most part, it's pretty damn flat compared to the on-axis response up until you get to, I mean, it's within 3 decibels no matter what, until you get around 6K or so. So at 6 kilohertz, now these things are starting to sound different. And you could argue that that's where the air and the magic lives, fine, but they kind of drop off the same. There's not that big of a difference between them. Though some of them drop off earlier, some of them drop off later. But it's still, I mean, until you get to 5K, these things may as well be on axis. And that's what we talk about. It's not that bass is omnidirectional and treble is totally a ray. It's a spectrum. It behaves more and more ray-like as you get up in the higher frequencies, and more completely omnidirectional like as you go into lower frequencies. One of the benefits of growing up in Hawaii and being around the ocean all the time is you get to see waves do wave things. And when you see waves go around a wall and form the wave on the other side, you start to get an idea. You especially get an idea why isolation is so hard in studios, right? Anyway, so let me go on. The AKG 414 seems to be the outlier here, but because I placed the microphones with my hands and rulers and not a robotic system, and I didn't take time to average multiple measurements, sorry. Maybe it wasn't exactly at 45 degrees, or maybe it's simply less directive than the others because the capsule is smaller, I don't know. Also, anything above the bandwidth of my microphone is not accurate, so I don't have an infinite dynamic range in my measurement setup. Here's 90 degrees. And even at 90 degrees, man, everything's pretty much within plus or minus 3 decibels until you get way up there. At least 5K, some of them closer to 10K. The pattern selector on the 414 was definitely on cardioid, but it seems like a wide cardioid to me. Maybe it's normal. Anyway, here's 180. And at 180, now you got some drastic changes. However, all the mics are very similar to each other. I'd say they're more similar than they are different, though that they are different. So what can we conclude from these graphs? I'd say that any modeling will be all right for sound coming out of the front part of the microphone. So let me say that again. I'd say that any modeling will be all right for sound coming at the front part of the microphone because the frequency response doesn't change that much apart from some peaks and dips of a few dB only. For sounds coming at the rear port of the mic, however, not so much. We'll test how audible that is. So that's great and all, but and are you really miking things 180 degrees off, or are you worried about, you know, what the off-axis response is going to do to things? So he says, so that's great and all, but I compared 4 mics with similar architecture, 1-inch double-sided capsule parallel to the body. The off-axis response will not be the same for mics with a different architecture. With that in mind, I'll try a DIY mic modeling. I will try to DIY a modeling mic with the worst, but still capable mic I can think to do that. Some examples with the DIY modeling mic, and throwing the Townsend in here too. Says I'll use an Octava Mark 012 and try to model the AKG C12. So an Octava MK12 to a C12. I bought the Octava for 150 euros, so it's one of the cheapest small diaphragm condenser mics available. Before the war, almost doubled its price. It has nothing to do with the C12 VR. One is a cheap, small, single diaphragm, transformerless condenser mic with the capsule perpendicular to the body, and that is a small diaphragm when they say SDC. The other is a 5,000 euro large dual diaphragm tube condenser mic with the capsule parallel to the body. Here are their on-axis and off-axis magnitude responses. And, man, it's kind of scary because they generally, again, still have the same trends of what happens with on and off-axis. There's some greater difference, I think, in the MK012. It's with like 3 decibels, though, so I know 3 decibels sounds like a lot, but I think it is in this situation. But he says widely different. We can see that the C12 VR drops off sooner than the Octava in the high end when the sound is off axis. That's because the capsule is larger. When sound comes from the side of the capsule and its wavelength is smaller than the diaphragm, the positive and negative parts of the wave will both end up on the diaphragm, resulting in cancellation. Because the Octava's capsule is smaller, the wavelengths need to be even smaller for this effect to occur. And let me just say this now, because I think a lot of people don't know this. The small diaphragm condenser is going to have a better frequency. All else being equal, the smaller diaphragm mic is going to have better frequency response. It can be flatter. All else being equal, the bigger diaphragm can have a higher signal to noise ratio. So those are the pros and cons. Now, people talk all this massive magical nonsense about mics, but that's really what the diaphragm size comes down to. Okay. We also see a heavy scoop at around 3K for the off-axis response of the Octava, and that the overall volume doesn't drop as much until 60 degrees, with a substantial drop at 75 degrees. I don't understand this latter behavior. Maybe some mic experts will tell me why. And that's some really fun stuff about research, is that it usually raises more questions than it answers. That's fun. I have designed an EQ preset to adjust on-axis frequency response of the Octava to the one on the C12 VR. I also threw the Townsend mic with the C12 emulation loaded, different revision of the mic, so I don't expect a miracle here. All the recordings you're about to hear are captured on a transparent, discrete preamp and in my home studio with substandard acoustics. I guess that's good. It's going to be a stress test. I won't reveal the mics and the file names, so that is a true blind test, but when I feel that the differences are definitely audible, I will write the name of the mic. The vocal recordings have some very subtle reverb. I think it makes the comparison a bit more natural. The other recordings are completely dry. Let's test them, shall we? So he says, vocals. Here's a vocal with the singer at 20 centimeters of the mics. So this is C12 VR versus Octava versus Townsend. So let me see. Let me see if these files are actually in here. Mic vocals 1, mic A, mic B, mic C. So I think this is going to be the same files. So let me make another project tab. Okay, only 1 second. I won't put these in here. Vocals 1. Oh, I got to unzip these. Sorry, hold on 1 second. Okay. Okay, vocals 1. but I just put them on a single track. Okay, so here's one mic.
I will always love you.
I guess I could put them on separate tracks so we can get exactly the same. Okay, let's get this long phrase here.
How I do let go of a prayer for you. Let go of a prayer for you.
So that's mic A.
Let go of a prayer for you.
Mic B.
Let go of a prayer for you.
That's mic C. I hear a lot more highs in that one. I mean, we're looking at Reaper with the spectral peaks, so it's kind of cheating. We can actually see some little bits of differences. A little bit more black, which is the highest frequencies on that Townsend. But between the C12 and the Octava, I don't know which is which.
Let go of a prayer for you. Let go of a prayer for you. Let go of a prayer for you. Let go of a prayer.
I don't know. Is one better to you than the other? I don't know. I'll tell you what. If you can't get a decent album out of either of those sounds, you suck anyway. It kind of doesn't matter. So here's what he says. I think my DIY mic is close enough. The Townsend, on the other hand, it sounds nothing like it. Yeah. Okay, so that was it. Remember, like, look at this, actually. So take a look at... in fact, let's do this real quick. We're going to look at spectral peaks here. View where is it? Peak display settings. Okay. I'm going to go to spectrogram. You know, spectrogram looks close. It's actually a little hard to tell, but man, these two guys look a lot closer, the A and the B. Let me go back to spectral peaks. You can definitely see a little bit more black in the Townsend, and you can kind of hear that as maybe some sibilance. Let's see again.
Let go of a prayer for you. Let go of a prayer.
You can see it. I mean, right here.
Prayer.
Let's try on the other ones.
Prayer.
It's there, but it's not as much.
Prayer for you.
Now the A and B, the first two, they're so similar. I know the purists or whatever are going to say they're completely different, but whatever. Okay, so here we go. So he says, I think my DIY mic is close enough. The Townsend, on the other hand, sounds nothing like it's an emulation of the original C12, I believe. So if you want to get the sound of the C12 with the C12 VR, think again. Now, that's an awesome thing to throw on somebody's face, too, all right? Says vocals further. You can hear my very bad home studio recording room through the mic, so let's increase the distance. Here's a recording with the singer 50 centimeters from the mics. Okay, now when we talk about off-axis response, here we go, right? We're gonna hear that the room's gonna leak in a little bit. 50 centimeters, that's a bit. So let's try those out. So I'm assuming that's mic 2. Here in the files, let me pull those up. Vocals 2. Separate tracks. Okay, so let's try these.
Por la blondarina que l'âme elle meurt.
Okay, here's another one.
Por la blondarina que l'âme elle meurt.
Okay, I hear more highs in one of these mics. I don't know that I like it, but I do hear more.
Por la blondarina.
Okay, listen to this. I think it's a D.
Por la blondarina.
Right there. Versus.
Por la blondarina.
I mean, you hear it, but I don't think you hear it as much. And I think I'm seeing it on this as well. Let's listen to the Townsend.
Por la blondarina que l'âme elle meurt.
Much more treble on
Por
that.
la blondarina.
So there's a tail right here. Let's see if we hear more of the room right here. Let me try the other mic. I'm telling you. Look, I know we all obsess over this stuff, but I really don't think it's gonna make any difference in a mix that matters. Sorry. I know that throws all my credibility out the window, but what credibility, right? Okay, so he says, same as the first example, at least from my ears. So then he goes on to some pianos. What about larger sources? Playing different performances, hard to tell. So when he does the snare, he says there's a big difference. Whether it's a difference in the... Hold on 1 second. I'll get this later. Whether it's a difference in the proximity effect or the difference of off-axis response, I don't know. The difference is so big that I wonder if the octave fell off the stand in a way that's damping the head of the snare. Okay, so let's look at these. Okay, so snare. Okay, and in this case, he actually tells us what the files are. So here's the C12. And here's the octava. It's almost like there's more proximity effect, huh? Interesting. Let's see what he's talking about the snare 2. And I don't know which is which on here. He didn't label them. It's just A and B. And what's the difference here on this one? Hold on, let's see. Large source 3 close snare. So let's try the Townsend without any emulation loaded, but with an EQ that adjusts magnitude response to C12 VR. So that's just C12 versus Townsend. Sound pretty damn much the same. Sounds much closer to me. That's what he says. Okay, G, off-axis source. Now this is where it's going to matter, right? Allegedly. Sometimes you're recording multiple instruments at the same time, but you want to separate them with different mics. Different mics will yield different levels of spill, like all important isolation, right? Here's a recording of an acoustic guitar with the placement mimicking how a mic placed for vocals will capture the sound of the guitar the singer is holding at about a 90-degree angle. So think about that, like when somebody's playing and singing at the same time, what angles is your voice entering the mic from? You definitely hear the mid scoop and high peak of the octava that appeared on the measurements. The other two, not so much. Now, is that going to matter? Let's see. So off-axis source. Where is it? I think this is going to be it. I don't know who's who. Yeah, should I have a different one? Now they are different. I can't say that any of them are bad. Let's maybe we could see something in the spectral peaks here. Let's see. Not so much. Let me get back to this. Okay. Room mic, diffuse field. But again, neither of us is going to make or break a recording, right? Sometimes the sound doesn't have a preferred location, just like the reverb of a room. So what if we try to do mic modeling with room mics? What response do we have to correct to? The answer is the diffuse field response. In this article by Shefts, we see that the diffuse field response has a distinct high-frequency roll-off compared to the free field on-axis response. And you can actually see this in this graph that they provide. So with my DIY mic modeling, how can I calculate the diffuse field response of my mics? I will need to average responses from multiple angles and a lot of them. I absolutely do not have time for this. I just recorded a guitar in a reflective living room with the Octava and C12 VR as room mics, with the rear of the mics facing the guitar so that the direct sound is minimized. Then I use Fab Filter's EQ match on Pro Q to calculate the difference. It got me this curve to apply on the Octava. So let's see how that goes. That's the diffuse field response. I don't know. Again, this is A and B. I don't know which one is which. Let's give this a little loop here. Okay, here we go. Okay, let me try the other one. I think we can tell that they're different, but I don't know that I care which one is which. Does that make sense? Says, sounds pretty close to me. It's noted the Townsend plugin provides some diffuse field equalization, but as the C12 model sound too far from the C12 VR, I didn't want to bother. So number 5, conclusion. What did we learn from this? Mic modeling works great in a lot of situations. However, when miking some large sources or dealing with off-axis instruments, differences in off-axis response are going to be audible. Thankfully, according to the limited samples I measured, it seems that mics with a similar architecture will yield similar off-axis characteristics. So, like, let's say you have a side address mic versus a pencil condenser with the thing on the perpendicular to the body. So it's perfectly okay to model a large diaphragm condenser with another large diaphragm condenser and it will give you similar results. However, modeling a large diaphragm condenser with a small diaphragm condenser will not work in some situations. The off-axis guitar sounded completely different. I don't know that it was bad, though. As a photography... Okay, so how do we approach microphones with that in mind? Here's my take. As a photography enthusiast, here come the analogies, but that's okay, right? I like to compare this to the choice of camera and film stock. You got 3 approaches here. The old school. You use film cameras and you change the film stock according to what you're capturing. It's the same thing for microphones. You don't care about EQ. You want it to sound great as soon as it's captured. So you choose the mic that suits the best the source. Hey, Devin. The new school. You don't know how to use film cameras and you don't care at all. Your mirrorless digital camera has better dynamic range anyway, so you'll color grade in post to achieve anything you want. Same for microphones. You have a few select workhorse mics that you'll throw on everything. Apart from choosing the appropriate form factor, weight, polar patterns, LDC, SDC, dynamic, ribbon, shotgun, etc. for what and how you're capturing, and your mics will take EQ well. You'll be able to create whatever sound you want in post. That's kind of my approach. The Gen Z that wasn't born in the right generation. You like film cameras, but you don't have the money for that. There's a solution. Use a digital camera with a great dynamic range and put some high quality film stock emulation on top of it. So you guys do saturation plugins, right? Oh, I wish I was around on the days of tape and analog consoles. No, you don't. You still need the appropriate sensor size to get the emulation correct, but if you do that, is anyone going to notice a difference? Nope, I don't think so. You did miss the process, which is the important part of it. However, you're able to get the same results. This is mic modeling. You just need to provide a mic with sufficient bandwidth and dynamic range and use the manufacturer-provided frequency response to linearize it, and then apply an EQ to mimic any other mic with similar architecture. If you want to do that but don't want to bother with the measurements thing, you can just buy a modeling mic from Universal, Antelope, or Slate, while I can't attest the exact quality of the modeling, it's unlikely that they can mess this up. All right. So let me show you something. One of my friends sent me this or gave me this mic the other day. We're doing some vocal recordings, and I guess he had just ordered this off Amazon or something. And so this is the it's this cheap mic. It says U87 on it, believe it or not. It was so cheap that the XLR cable that it came with was plastic. The threads on the mic on the shock mount for it are plastic. I did a little video on Instagram. You can go watch it where I took the thing apart. But let me play this for you. And this already has a little bit of compression and reverb on it, so it's not going to sound exactly the same. I can take those off if we need, but let's just listen to it in context real quick. So that's a super duper pooper scooper cheap plastic mic. And here's an AT4050. It's funny because we were just talking about that, right? Now these are two different vocal takes, but even if they weren't, one thing that you can see here, because we're looking at spectral peaks. Let me zoom this in. Notice this blue. This is the background noise in that room, and it's picking up more low frequencies than the other mic. But I'm going to take all the effects off of these things now. I'm going to take all the effects off everything. Just listen to these things raw. Okay, that's the cheapo, and here's the 4050. Now, it may be that she's actually distorting some of these a little bit more, so I'm just going to loop the first ones. But first of all, you hear maybe the 4050 is not as bright, or you could say it has more lows. Let's go with that. Throw an EQ on here. Now, one comes free with your DAW is fine, but I want to show ours because I'm pimping out the gear, right? So let's a slightly different pitch, but let's ignore that. Let me take a high shelf here. I'm just going to turn down the highs in general, like 3 decibels. Let me just mute everything real quick. Now, I know there's some volume differences, and again, it's still a little bit brighter. Let me take this down even more. And maybe I'm gonna add some lows to it. Let's do a low shelf. Oops. Help if I turn this thing on, huh? Hold on, give me a second. Oh, that's way too much. Now, aside from them being two different performances, are those mics really so different now? Now, who knows? It might not be reliable at all. It might fall apart the next time I turn it on. But you talk about sound. If you can't get a decent album out of either of those sounds, you suck anyway. You're gonna have bigger problems than this. So that's about it for that. Let me oh wow, we've been going for a while today. All right, let me move on to the next thing. So this is an article. We were just talking about We were just talking about impulse responses the other day. We actually did a lot of stuff. This is from Eric Klein from Line 6, and this article is called Eric Klein, at least half of your modeler's sound is determined by your playback system. Now, you know, Glenn Fricker got a lot of crap because he's saying, you know, your pickups don't make anywhere near the kind of difference to your guitar sound as your choice of speakers do. And sorry, but he's pretty much right for the most part. I mean, you could have broken pickups or something, or single coil versus humbucker, but even that doesn't always make that big of a difference. It usually does. But so he says, when you read the phrase "the sound of a Marshall JCM 800," what is the first thing that pops into your head? Are you standing in front of a half stack? Maybe seeing a certain band at a large venue downtown, listening to a particular recording while on a road trip. Oops. There's no wrong answer, yet the experience of hearing a JCM 800 in each of these environments couldn't be more different. Although many of us in the industry loathe the term, in the first example, you're experiencing what is known as amp in the room. I dislike this term, if only because it should be cab in the room. And I guess that's true. One of the reasons we dislike it is that nobody likes the actual sound of the amp in the room. On a recording, they like the sound of a 57 or whatever shoved right up in the microphone, like really close to it, like half an inch away, or you know, maybe a little further, but very close, not anywhere near where you'd put your earballs at, you know. So that's why the amp in the room sounds kind of silly, but you know what they're saying. They want it to sound like when they're playing their amp, you know. But you know, move your head an inch, and the whole everything sounds different anyway. All right. So he continues, the guitar speaker in the cabinet it is in vibrate air molecules which propagate in sound waves that vibrate your eardrums. Chances are the strongest vibrations hit your knees unless you're facing a full stack. And if you're smart, you're not turning the master volume knob past halfway. In smaller venues, the band may be on a 5-foot stage, so the cab is pointing towards your face. Or it could be across the stage pointing somewhere completely different. In large venues, the sound of the guitar is mostly coming from the PA system via a microphone pointed at the cab speaker and run through the front of house console. Remember that. When you idiots bring these gigantic amps onto these tiny little stages, you're taking away the ability of the sound man with the PA system to actually give your audience a good mix. You're determining what the minimum possible volume for your guitar is, and now they're going to have to make everything else match that, and who knows however much leakage is coming off your stupid loud amp off the stage anyway into every other microphone up there. You're wrecking it for everybody. Cut that crap out. Okay. When you listen to your favorite records, the room in which the guitar amp was recorded, the microphone used to record it, the placement of the mic preamp, and any other outboard gear used, the analog to digital conversion, digital processing, mixing, especially when you're trying to get the guitar to sit right with the rest of the instruments, and mastering can drastically change the sound. What you hear is likely totally different than what the guitarist experienced at that day in the session. Yes, very different. Now consider the myriad methods of listening to that recording, from cassette decks in older cars to budget Bluetooth earbuds on your morning jog to $100,000 audiophile systems in acoustically neutral listening rooms. It is also common for session guitarists to place their cab in the tracking room, but play from the studio control room, listening through studio monitors along with the producer and engineer. This lets them crank the amp's volume to hit its sonic sweet spot while avoiding ear damage. In other cases, they may forego the cab altogether and run the amp, again, this is with the master volume louder than they normally play through the cab, into an attenuator load box and utilize cabinet emulation or impulse responses. But which of these is the sound of a Marshall JCM 800? All of them. The amplifier hasn't changed, but the playback systems and the environments are completely different. Your playback system and listening environment account for at least 50% of your tone and well over 50% of your experience. Okay, so it's the playback system. Can't modelers fix bad playback systems? I'll answer that question with another question. Can't turntables convince you that your favorite band is actually playing in your house? I don't know that I'd go this far, but let's see. A better turntable can't convince you the drummer is behind you, the singer's in your kitchen, and the bass player is passed out behind the sofa. At the very least, you'd blame your decidedly non-Dolby Dolby Atmos home stereo and not your turntable. The point is that all these pieces of gear, your turntable, your hi-fi amplifier, your surround sound system, their material properties, location in the room, acoustics of the room, playback volume, and others, all perform together as an open system, and a system is only as good as its weakest link. Again, I don't know that I would say as good as, but I would say that they all contribute. While modern professional modelers such as Helix Floor can completely nail the sound and feel of end-to-end closed systems like preamps and power amps to the point where top LA session guitarists and golden ear engineers state they're indistinguishable from the real thing in double-blind ABX listening tests. Well, that is some claims, but it's line 6 right in this, and for the most part I agree. Sorry. They have absolutely no clue about and certainly no control over what you plug them into. Until the technology exists where we can bypass your ears and tap directly into your brainstem, no amount of digital trickery will ever enable a 1x12 cabinet to make you believe there's actually a 4x12 in the room, much less convince you that a plastic PA speaker is a wooden cabinet with guitar drivers, or your broken 4-inch computer speakers aren't hot garbage. The laws of physics dictate this, not any lack of DSP sophistication. I don't know that I would go that far, honestly. I think that if we put a curtain up or blindfolded a guitar player and put a 4x12 in the room and a PA speaker with the proper IRs in that same room, I don't think you'd be able to tell which one's the 4x12 and which one's not. So anyway, so he says, so what's the right playback system for digital amp modelers? It depends on what you're trying to accomplish. Let's take a look at your options in no particular order. FRFR speaker, PA speaker, headphones, IEMs, in-ear monitors, studio monitors, standalone power amp, real amp cab, and the real amp cab. So if FRFR speaker. FRFR stands for full range flat response, and they are typically wooden cabinets that look like real guitar cabs, except that they're often two speakers, a low frequency driver, woofer, and a high frequency driver, tweeter. They're designed to be flat and accurate, almost like a studio monitor you can bring on the stage. Pros: a good balance of sound and feel when amplifying a wide variety of cab models or impulse responses. Looks like a real cabinet. The audience hears what you hear on stage. The audience hears what you hear on stage and what you hear in the studio. When I wrote those articles bringing the studio to the stage, this is really what I was after, right? Like, how do I get that exact sound coming out of my studio monitors to come out of the stage where the audience can hear it? Cons: still may not respond exactly like that one guitar cabinet you know and love, even if it's the same configuration, 1x12, 2x12, 4x12, etc. The high frequency driver can sometimes sound a bit strident, although this can often be dialed out from the modeler's global EQ. More expensive than other solutions. Okay. Best for guitarists who want to embrace the wide variety of amps, cab emulations, and IRs found in modelers, but don't want to sacrifice the look of a wooden cab. I don't give a crap about any of that stuff. So then he separates FRFR into a different one, distinguishes it from the next category where he says PA speaker. Pros: more affordable than FRFR speakers generally, robust construction, often the most convenient portable solution. Flexible orientation, many can be used as a stage wedge, upright speaker, or on a speaker stand. Can sometimes connect additional sources such as vocal mics and be used for other things like, say, DJing a wedding. Cons: sounds less like a real cabinet. Frequency response is sometimes hyped or scooped to sound better for music playback, even those marketed for guitars. Feels less like a real cabinet, looks less like a real cabinet. I don't know. First of all, I don't really believe there's a difference between a PA speaker and an FRFR speaker. Either one might be hyped. They might have some DSP with some weird EQ in it. I think any of the good ones you get, you can change that for yourself. I know, and even on my cheap Alto, I got a Bluetooth app where I can EQ from it. I don't know that it's going to feel less like a real cabinet. It could look like less than a real cabinet. It's cheaper because guitar players are nuts and they pay extra money for dumb crap. So just because the thing says FRFR on it instead of PA speaker, I'm sure they were going to pay more. Headphones, in-ear monitors. Pros: clearly the most convenient portable option, maybe easier to hear detail, especially in noisy environments. Proper in-ear monitors are what most large touring acts are using these days. I mean, think about silent stages, right? In larger venues, you hear what the audience hears. Cons: massive range of quality from excellent high impedance over-the-ear open back studio headphones to hot garbage, low impedance consumer earbuds. Sound and feel very little like playing through a real cab. Yeah, I'm trying to get used to that right now. Well, maybe we'll talk about that in some other show. Sorry. Best for guitar players who want to practice or rehearse on the go, live in apartments or other reasons can't play through loudspeakers, embrace silent stage monitoring, or are comfortable with how recorded guitar sounds as opposed to how cabs sound in the room. Studio monitors. Pros. Better studio monitors typically have the flattest, most accurate frequency response, provided they have enough bass. Your writing rehearsing tones will most closely match your recorded tones, making it easy to transfer sounds from studio to stage and back again. If you record, you probably already own them. Cons: unless you splurge for studio monitors with 8-inch or larger woofers, the low end may be lacking. May not be loud enough for practicing with others or gigging unless you play coffee shops. Feels less like a real cabinet. I don't know about that one. Not meant for live performance. Yes. Best for guitar players who spend most of their time in the studio and are comfortable with how recorded guitar sounds as opposed to how cabs sound in a room. And that's me. So I dial all my sounds in on these HS5s with the subwoofer, and then I take them over my FRFR cabinet, and I couldn't be happier with how close they sound together. Though when I try with the Celestion F12 that's supposed to be made for this, I don't like the sound as much. It's kind of weird. I'm not sure if I'm just using the wrong cabinets or what. He goes on to standalone power amps and real cabs. But if you're using the real amplifiers, real cabinets, you're giving up your ability to change between IRs. So I don't know if that really matter. He says, this sounds more like an ad. There are also Line 6 Power Cab active guitar speaker systems, which are different than all of these. They combine powered wooden guitar cabinet with the ability to virtually swap out different drivers. But no, it's a powered, it's a PA speaker. Come on. So it says, what can I do to make my playback system behave more like a real cab? Start out with the model of an amp and cab combination you know well. If you never played through a real Rev generator, 120 or Grammatico GSG 100, there's no baseline from which to compare. 2. An amp model's default values often have the master parameters turned up because that's where the real amp sweet spot is. However, tube amps are loud, so if you're used to playing at bedroom volumes, of course it won't sound like a roaring full stack. Turn your playback system up. If you can't or aren't allowed to play at louder volumes, turn the master parameter down if your modeler has one to approximate your playback system's level. Try placing your playback system in the same location and point in the same direction as you would a real cab. I guess we could talk about coaxial versus discrete drivers. If your tweeters, like the Celestion F12 or the turbo sound monitors that a lot of people are using for FRFR now, it's a concentric tweeter, right? 5. In the cab block, experiment with different microphones at different distances and positions, or with IRs, choose one with a different microphone distance to speaker and position. Condenser microphones at a greater distance tend to sound more and more amp in the room, whereas a Shure SM57 right up against the grill will more closely approximate what you might hear on the record. 6. Add a touch of ambient reverb to your sound, especially when using headphones. The little goes a long way here. Lastly, a favor. Whether online or in meet space, the next time you encounter a new user struggling with amp modeling, before you start rattling off suggestions like adding low-cut filters, downloading different IRs, changing the input buffer, try the following. 1. Ask them what their expectations are. Are they expecting to get the feel of the amp in the room or the sound from a particular record? Do they have experience in front of one specific cab, and are they chasing that? 2, ask them what their playback system is. Chances are it's not a real cab. Might be something particularly egregious like a plastic PA speaker, smaller studio monitors, or headphones. Hey, my PA speakers are plastic and they're just fine. 3, share this post with them. So thank you, Eric. Okay, one more thing. Right when we're on here, I just got a message from our programmer, Dave. Okay, this is Intuition. It's a new alpha for one of our compressors. Let me grab it now. Close Reaper. We're gonna okay, we open this up. Should drop this new version of the plugin in. this does this. Sorry, 1 second. So I don't think this one's gonna have bus mode. It says version ends in FB2. Again, turning on the bus mode toggle is the feedback mode. Also, this is Windows. Okay, hold on. Pull this up. And let me pull up a pull up this file here. Okay, so the one I really care about, so it's mostly bass and vocals, right? Where we talk about feedback and feed forward. So let's take a look here. I'm gonna solo these vocals.
I need a little sunshine.
Let me find a problematic spot. That's actually too smooth. Try this phrase right here. Hold on.
'Cause I depend on you. 'Cause I depend on you. My habits are hard to beat, but I'm still.
Oh yeah, here we go. So this is going kind of high and low. So let's check this out for
My
a compressor.
habits are hard to beat. My 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 habits are.
So I'm gonna make this kind of even out the volume here. I'm doing a lot of compression. You probably wouldn't do this much, but let's just, I'm doing this for exaggeration.
My habits are hard to beat. My habits are.
Okay, so this should turn on the feedback mode. So this feed forward right now. Here comes feedback.
My habits are hard to beat. My habits are hard to beat. My habits are hard to beat. My habits are hard to beat.
So I don't know if this is a little bit quieter, but maybe not. To me, it just sounds smoother and warmer. I know those are horrible weasel words, but in general, that's what I find with feedback versus feed forward compressors, and this is doing what it's supposed to do. I'll have a lot more on this later. This is a very early alpha. We're gonna do a lot more, but I've been on here for quite a while now, so I will see you guys next show or next stream. I've been streaming a lot lately, so